Hello class, today we're going over lesson 2.3, how to understand proportional relationships and find equivalent ratios. So let's get started. First thing we want to learn about is what is a proportional relationship. So here's our two definitions for today, proportional relationship and a proportion. So a proportional relationship is two quantities are in a proportional relationship if all of the ratios that relate the quantities are equal. So basically what we have to do is we have to find the ratio of all of the quantities and ensure that the other quantities we have that same ratio as well. Now next is a proportion. So a proportion is an equation that represents equal ratios, and we'll be coming up with those in a minute here. So let's go into our key concept for today. So we want to determine whether quantities are proportional by testing for equivalent ratios. All right, so here's our first example. The amount of seed a landscaper uses and the area of a lawn covered have a proportional relationship. We want to complete the table. All right, so for this first one, we find that we have 2 ounces of seed and it covers 50 square feet. Next, we have 3 ounces of seed and it covers 75 square feet. Finally, we have 4 ounces of seed and it covers 100 square feet. And what they are asking us to find is the area covered divided by the seed amount. So here for the first one, we want to find 50 divided by 2, because 50 is the area covered, so it's our numerator, and the ounces of seed is 2, so that's our denominator. Now 50 divided by 2 is 25, so this proportional relationship here is 25. All right, next we have a 75 divided by 3. Again, we get the 75 from the area covered and the 3 from the seed ounces. Now 75 divided by 3 is again 25 here. And lastly, we have 100 divided by 4. 100 divided by 4 one more time is 25. Now, since all of these numbers here equal 25, then we could say that they have a proportional relationship, which is exactly what we were told up in the beginning here. That these three, that the amount of seed that is used and the area of lawn covered has a proportional relationship. And we proved that by showing that all of these values here equal 25. All right, let's get into our next example. Is the relationship between the number of slices of salami in a sandwich and the number of calories present proportional? Explain. All right, well, let's find out here. So again, we're doing the same thing. We're going to do the number of calories divided by the number of slices. So here we have 66 divided by 1, which will obviously just be 66. Next, we have 96 divided by 2. And 96 divided by 2 would be 48. So right off the bat, we could see something's a little off here. Third, we have 126 divided by 3. And 126 divided by 3 is equal to 42. And then lastly, we have 156 divided by 4. And 156 divided by 4 is equal to 39. All right, so notice how these 4 values here are not equal. These are not equal to each other. We have a 66, a 48, a 42, and a 39. So it looks like the relationship between the number of slices of salami and the number of calories is not proportional. And the reason is because when we find the ratio of these, they are not equal. All right, here's another example for us here. Do the two tables show the same proportional relationships between x and y? All right, well, let's find out. We want to find out here x over y. So we're going to divide all of our x's by all of our y values. So first off, we have 160 over 360, and 160 over 360 will give us 0.4 continuing. All right, next we have 500 divided by 1125, which will give us 0.4 continuing. All right, so this is off to a good start, right? Because we already have two ratios that are equivalent here. Now, lastly, we have 1,200 divided by 2,700, and that will give us, again, 0.4 continuing. All right, now let's look at our second table here. So we know that all of our values between x and y are proportional on this first table, but it wants us to compare these two tables here. So now we have, on our first one here, 2 divided by 4.5, and 2 divided by 4.5 equals 0.4 continuing. All right, so we're off to a good start here. Next, we have 5 divided by 11.25, And 5 divided by 11.25 is again 0.4, continuing. And then lastly, we have 7 divided by 15.75, and 7 divided by 15.75 equals 0.4, continuing. Sorry, 0.4, continuing. All right, so let's go back to our original question. Do the tables show the same proportional relationship between x and y? Yes, they do, because all of our ratios for x and y equals 0.4, continuing. And as long as they are the same, they are proportional. All right, so for our conclusion, today we talked about proportional relationships, and we found those by comparing the ratios of 2 different items or 2 different data sets. We moved on to comparing data sets because we wanted to compare a large amount of data as opposed to just single units here. Alrighty, everybody, that's chapter 2.3 for us. Hopefully you guys understood this here, and I will see you all in class tomorrow. Please ask questions if you have them. Bye-bye, everybody.